To Electron Rules of Thumb, Lesson 1. In this lesson, we're going to discuss the definition of practical range, the formula to calculate practical range, and its clinical applications. Electrons have been used in radiation therapy since the 1950s, and they are very useful for treating shallow tumors. This tumor is situated just beneath the skin in the chest wall, and it sits very close to the heart, so ideally electrons would be the best treatment. Practical range is a concept in which we look at the actual distance from the surface of the skin in which an electron can deposit most of its energy. So there is a formula for this, but essentially it looks like it's visible on this graph. We have on the y-axis the percentage of dose that can be deposited from 0, 50 to 100%, and the x-axis represents the depth. So where we have the electron dose running out at the Bremsstrahlung region, and it crosses the steepest point of the depth dose curve, at that point, at that depth, that's the practical range. The formula for practical range is Rp equals energy divided by 2. It's a very simple formula. So how this can be used clinically is the physician could ask us what would be the practical range for an electron beam if they knew what energy they already wanted to treat with. So in this example, the physician knows that they want to use a 12 MeV electron beam. The practical range formula is Rp equals energy divided by 2. If we substitute 12 MeV into the formula, 12 divided by 2 equals 6 centimeters. So the practical range for a 12 MeV electron beam would be 6 centimeters, meaning that most of the energy would be deposited over a distance of 6 centimeters. As you can see, if this was the case, that a 12 MeV electron beam would deposit most of its energy to about 6 centimeters and then rapidly drop off. These colored lines represent different levels of dose, and you can see past a certain depth, we run out of electron dose and dose deposition, and we do not have any dose deposited in the normal healthy lung tissue. It can also be used to find out what energy we want to choose. So if I already knew what the dose or the depth was to the tumor, so this red represents the tumor, and if I knew it was 2 centimeters deep, I could calculate what energy I could use to treat that particular depth using the formula. So again, if Rp equals energy divided by 2, and I already know that I want to treat to 2 centimeters deep, I just plug in the 2 centimeters as my Rp depth. So in that case, by rearranging the formula, energy is going to be practical range times 2. 2 times 2 equals 4 MeV. So I would tell the physician that if he or she used a 4 MeV electron beam, they could treat successfully to a depth of 2 centimeters.